Hi there once again. In this video we are going to learn about radian measurements. Radians are another way to measure angles. You measure angles using degrees, but you could also measure angles using radians. We are also going to look at how you are able to work out the area of a sector of a circle, the area of a segment of a circle, and also how you work out the length of an arc in a circle. Alright, so let's see how you measure angles using radians. Alright, so you all know how many degrees you get if you go around one whole circle. You get 360. Okay, but if that same angle is measured in terms of radians, you have approximately 6.28 radians. Okay, so 360 degrees is equal to 6.28 radians approximately. Or there's a better way of talk about the 6.28 radians. We usually say that is 2 pi. Now that is a better value to use than 6.28. So 360 degrees is 2 pi radian. Alright, good. Now let's look at another angle. So if you have 180 in one straight line, so that same measurement in radians would be a pi. Alright, which is about 3.14. Alright, so it's just like inches and centimeters, where you'd measure lengths using inches or centimeters. You'd measure angle using degrees or radians. Okay, so because we know that 180 degrees is 1 pi, 90 degrees therefore would be pi by 2, 60 degrees would therefore be pi by 3. Okay, that's easy enough. Now we'll have to figure out a way where if you're given a certain angle, how do you work that out in radians? Okay, this is what you do. So you always know, it's very easy to remember this, isn't it? 180 degrees is a pi. So therefore 1 degree would be equal to pi divided by 180. You just rearrange it. Alright, so if you know 1 degree is pi divided by 180, let's say you were asked to give 27 degrees as in radian measurement. So 1 degree is this, so 27 degrees is, you got to times this by 27. So 27 times pi divided by 180. If I cancel this 27 with this 180, that's divided by 9, I get 20, divided by 9, I get 3. So that's 3 pi by 20. So that's in radian measurement, 27 degrees. So whenever you're given an angle in degrees and you were asked to work that out in radians, all you gotta do is multiply that angle by pi divided by 180. So that angle, unknown angle, is theta. Theta times pi divided by 180 gives you the measurement in radians. Okay, right. What if you need to go the other way? If you need to if you've been given an angle in radian measurement, 5 pi by 6, and you need to figure out the angle in degrees. Okay, let's figure out a way. You know that 1 pi radian is equal to 180 degrees. So therefore 1 radian should be equal to 180 divided by pi. So therefore 5 pi by 6 radians should be this times this, because 1 radian is this, 5 pi by 6 should be this times this. So let's multiply those together. Pi and the pi cancel, 6 and 180 cancel to give you 30. that is equal to 150 degrees. Okay, so if I were to summarize that, if you need an angle in degrees, you need to do that angle in radians times 180 divided by pi, and you get the degrees equivalent of an angle in radian. Okay, oops, that's not very neat. Good. Next we'll see how you work out the length of an arc. Okay, length of an arc. What is an arc? An arc is a certain portion of the perimeter on a circle, or the circumference, as you would say, of a circle. So this blue thing here is an arc. The whole thing is its circumference or its perimeter. So you've got to work out the length of this. Alright? Now, from primary school, you would have learned how to figure out the perimeter or the circumference of a circle if you were given its diameter or radius. Alright? So you have a circle here. So let's say its radius was 3 units. So its perimeter would be 2 pi r. So if you plug in the values into that formula, you get its perimeter, or I should say circumference for a circle. Circumference for a circle, right? So 2 times pi times 3. So that's equal to 6 pi. Alright, so the exact answer is about 18.8. Alright, good. Now this 2 pi has some significance now. It's no longer some random number that you've just had to memorize to work out the circumference, because if you go around the whole circle, it's 360 degrees. That is equal to 2 pi. Alright, so just stay with me there. So this whole circle is made up of 2 pi radians in angles. Okay, so again on that same circle, let's say I wanted to know the length of this arc, but that length was created within this area where you have 60 degrees. Okay, 60 degrees. Okay, so the circumference sort of works out in proportion to the angle across you've traveled. Alright, so if this is 60, I mean if you traveled across 360 degrees, that's 2 pi. Alright, but if you traveled through 60 degrees, if you work out 60 degrees as a proportion of 360, alright, so 360 as a proportion, 60 degrees as a proportion of 360, which is a sixth. So you would know the length of this arc would be a sixth of this result. Alright, which is approximately 3.1. Alright, but the most direct way to work that out is, now usually you do this, isn't it, to work out the circumference. So to work out the length of an arc, this is what you do. You've got to multiply the angle through which that arc is created. That angle should be given in radians. You should multiply that with the radius of the circle. Okay, now the angle through which this arc's traveled is 60 degrees. That in radians is, we've just looked at it, 60 degrees is pi by 3. So all I do is this. What I do is this, pi by 3 times my radius, which is 3. I ought to get my length of the arc, which is just pi, which is approximately 3.14, and the answers tally up, don't they? Alright, so that's all what you got to do to work out the length of an arc. You've just got to multiply the angle in radians times the radius. Okay, multiply the angle in given in terms of radians. Alright, okay, now we'll see how you work out the area of a sector in a circle. Now when you talk about sectors, it's basically a piece of pizza. This is what I mean by that. Okay, so that's a sector of a circle. Alright, now you know how to work out the whole area of a circle if I give you its radius. So if I say this is 4 units, you would straight away know what to do. It's pi r squared for the area of a circle. So that's pi times 16, so it's 16 pi, which is approximately 50.3 square units. Alright, but what if I said I want to figure out the area of a sector that, let me show you clearly what a sector is. So that's a sector, alright, which sort of travel through 90 degrees. Okay, I mean that's easy enough, isn't it? Because 90 degrees is a quarter of a pizza or something circular. Alright, so the area of this sector should be a quarter of this. It should be approximately 12.6 or something like that. Okay, right. But what if you were asked to figure out the area of a sector of some which traveled through an awkward angle? Let's say that was 120 degrees. How would you work that out? Okay, this is what you'd do. Right, now notice the significance of this pi, alright, when you figure out the area of a circle. Alright, so when you're trying to figure out the whole area of a circle, a whole area has 360 degrees but 2 pi radians, okay, in angle. Okay, but this formula has only pi. Alright, so if you are asked to work out the whole area of the circle, it's traveled through 2 pi radians, but in the formula you only have pi. So there you can sense that it's only half the angles in radians is what it's used to multiply here to figure out the area. Okay, so 90 degrees is pi by 4, isn't it? 90 degrees is pi by 2, beg your pardon, pi by 2, because pi is 180. Alright, but you only use half the angle that you've traveled through to get your sector in the formula. Okay, so it's pi by 2 divided by 2 or times by half times the radius, which is 4 squared. So that is equal to pi by 4 times 16, which is equal to 4 pi, which should be approximately equal to that, 12.6 square units. Alright, what about 120? Again, we get 120 in terms of pi radian, so that is equal to 16 pi by 3, which is approximately equal to 16.8. Alright, so 120 is 2 pi by 3, and then you got to half that angle and then multiply it by the square of the radius. Okay, so if I were to summarize that, to work out the area of a sector, this is what you do. You get your angle in radians, and then you got to halve it, and then you've got to multiply by the square of the radius. Okay, again, angle in radians. Okay,